So day 6, September 5th, applications of polynomial equations. So really similar to what we did Friday. In fact, there's really nothing new like concepts to discuss. We're just going to jump in and work some example problems. Find the value of k given that 3 is a root. Okay, if 3 is a root, what are some other things that means?
X minus 3 is a factor.
X minus 3 is a factor. And what else does it mean? How can I check this? Or if it's a factor, what does that mean? It's divisible. And if it's divisible, what am I aiming for? What's the remainder equal to? 0. So that's a good thought process. If 3 is a root, x minus 3 is a factor. Which factor means it's divisible, means the remainder is 0, which means, okay, I know what to do to get a remainder. I can synthetic divide this thing, and I should get remainder 0. Or maybe I'll force it to have a remainder of 0. Multiply, add, multiply, add, multiply, add. There's a lot of multiplying and adding and synthetic division on the test, so I hope you can do it quickly and accurately. How do I add k and 9? 9 plus k plus 9. Multiply by 3, so 3k plus 27. 3k plus 25. But that's supposed to equal 0, because 3 is a factor, which means it doesn't have a remainder. So k equals negative 25/3. The other way to... I don't know that I would even do it the other way. It also means that f of 3 equals 0. But I don't want to plug in 3 because then I have to deal with 3 to the 5th and 3 to the 4th and 3 cubed, and it would work, but synthetic division is usually the way to go. Number 2, polynomial g is an even function. Okay, so that means it's like doing the same thing on each end, both up or both down. G of negative 2 equals 5. Okay, I'm going to sketch that. G of negative 2 equals 5 is a relative minimum of G, so something like that. Which of the following statements must be true? Oh, even function means even more than that. What does even mean? It's reflected over the y. So whatever's going on this side will get reflected over to this side. Again, I don't know what else is going on in this equation, but maybe this is enough. G of 2 equals 5 is a relative minimum. I think that's right. G of 2 equals 5 is a relative maximum. No, that's not it. G of 2 equals negative 5. No, that'd be like if it was an odd, right? If it was an odd function and got reflected over here, but that's not it. So yeah, it's A. Oh, here we go. Speaking of odd, polynomial function is an odd function. Origin symmetry. If h of 4 is negative 6, again, this doesn't have to be a perfect picture. It's a relative maximum. Oh, so that's the top of a hill. Which of the following must be true? So origin symmetry is rotated 180 degrees. So what quadrant is this piece going to rotate into? Let's get that way. Rotate into there. And when I rotate it, is this point going to become a minimum or a maximum? A minimum, because it's going to look something like that. So I think it's going to be back 4 and up 6. So h of negative 4 equals 6, and it should be a minimum. H of negative 4 equals 6, and it's a minimum because it got rotated around. Number 4. P of x is a 4th degree polynomial function with integer coefficients of roots 1 plus root 2 and 2 plus I. Write P of x in standard form. 4th degree. 4 answers. I only have 2, sort of. Right? What are my other answers? Knocking stuff off up here. So 1 minus root 2 and 2 minus I. But what do I do to get that into some sort of standard form? X minus 1 minus root 2, x minus 1 plus root 2, x minus 2 plus I, x minus 2 minus I. Ugh, awful. So, there's kind of 2 ways to do this. I could distribute the minus sign and then do 3 terms by 3 terms. Or I could leave the minus sign and treat it almost like a FOIL problem. I don't know. You got a preference? It's not particularly pretty either way. At the risk of being confusing, I'll do it one way and one the other way.
Why would you do x minus?
Because it's always x minus, right? If x equals 3 as a root, then it's x minus 3. If x equals negative 2i as a root, then it's x minus negative 2i.
So you just set those in the problem equal to x
and then multiply it out. I'm going to do the first one like a FOIL problem, and then I'll do the second one as a after I distribute the minus sign. Then we'll just figure out which one we think is better. So x squared minus x times 1 plus root 2 minus x times 1 minus root 2 plus 1 minus root 2 times 1 plus root 2. Right, so I treated that one as a FOIL problem. I don't know if that was the best choice or not, because there's still more work to go. X squared minus x minus root 2x minus x plus root 2x plus 1. Those are conjugates, so a lot of that will go away. Minus 2. So all of that to get x squared minus 2x minus 1. Yes? No? Okay. So on this one I'm going to do it the other way. I'm going to distribute first. X minus 2 minus I times x minus 2 plus I. And then I'm going to distribute the x, distribute the minus 2, and distribute the minus I. So I'll have 9 terms, but I'll be done, right, rather than having to FOIL again in here. So if I distribute the x, x squared minus 2x plus ix. Then I distribute the 2, or the minus 2, careful. Minus 2x plus 4 minus 2i. And then distribute the minus I, minus ix plus 2i minus I squared would be plus 1. So we combine like terms, we get x squared minus 4x all the i's should go away, right? That's the point of them coming in conjugate pairs like this. ix, 2i, 2i, and then 4 plus 1 is 5. And then now I get to multiply these two together. So again, I like my color-coded strategy here. So I'll multiply by x squared, then I'll multiply by 2x, then I'll multiply by -1. By the way, there's not one this bad on the test, if you're worried. Let's see, so x to the 4th minus 4x cubed plus 5x squared. There's my x squared distribution. Now for the minus 2x. Minus 2x cubed plus 8x squared minus 10x. And then the minus 1 minus x squared plus 4x minus 5. Let me finish it, and then I'll tell you how it's on the test. So x to the 4th minus 6x cubed 5 plus 8 is 13, minus 1 is 12, 12x squared, and then minus 6x minus 5. Yeah, there's not one like that on the test. On the test, that idea is tested. I don't remember which one it is, but it's like, it's one of the two. It's not both in the same problem. So, you either have to multiply out the I stuff or the square root stuff, but not both in the same problem, because that's just kind of ridiculous. Okay, this looks like a common difference type problem set up here. Alright, so the reminder is, for a quadratic, second differences are the same. For a cubic, third differences are the same, and so on. The table below, find the degree of this thing. Let's see. Just not wanting to do this problem. Do you know how to do this problem? Differences. I wonder if I could start in the middle and make my life a little bit easier. Right, I'm doing the easy numbers. So that's my first difference. Clearly not linear. A quadratic would be the second difference. So that is a plus 40 and a plus 4 and a plus 16. So not quadratic. Cubic. Not cubic, because that's down 36 and up 12. And I won't know if it's quartic because all I've got is one answer. Right, I'm up 48. So I need one more sort of diagonal coming in there to see if those match. Let's do this end. This end looks a little bit easier. That's 93. That's 76. That's 60. And that's 48. Okay, we got a match. Yuck. Yes, it's quartic. Is that tested on the test? Yes. Is it that terrible of a problem? No. Average rate of change. I feel like we did one of these. Yeah, we got plenty of time. Average rate of change of W with respect to X. So average rate of change, that's just good old slope formula. Change in Y over change in X. So from -4 to 2 means I need W of -4 and W of -2. Let's see, how much can we skip at once? 16 plus 8 plus 2 is 26. W of -2 would be 4 plus 4 plus 2 is 10. You know what? While I'm on a roll, I'm going to go ahead and do all of those because they're spaced evenly. So W of 0, W of 2, and W of 4. W of 0, that's the easiest it gets. W of 2, 4 minus 4 plus 2 is 2. I wonder if W of 4 is going to be 10. 16 minus 8 plus 2 is 10. Okay, so 16, I guess I should show my work. 16 over 2 is 8. 8 over 2 is 4. 0 over 2 is 0. And -8 over 2 is -4. I feel like I did that in a strange way, but an efficient way. Rather than find all the average rate of change, I found all the values, and then I found the rates of change. Part B. Find the first differences in the average rate of change. Okay. 4, 4, whoops. -4, -4, -4. Like, how do I get from one to the next? I subtract 4. I don't like how that's worded, but it's a first difference in the average rate of change. But the average rate of change is already a first difference. Does that make sense? So that's misleading to say that the first difference is -4. You have to say the first difference of the average rate of change is -4, which means the second difference, the first difference of a first difference, is a second difference. That equals -4. Yes, sir.
Quick question. So when you calculate the rate of change, would it be the other way around? Would it be like W is -2?
Did I do that backwards? I did do that backwards. That's what I was trying to do too quickly. Yeah, so those should all be negative. Is that, well, they should be opposite sign of what they are. Good catch. That's what happens when you go too fast. That's what I'm worried about with my 17-minute test performance, is I did something like that somewhere.
Wait, can you explain B again? I just
So find the first difference of the average rate of change. Okay, so this table, this line is the average rate of change. The first difference is 4 each time. Okay, that's all it asked for. Maybe my question is going to come up with C. What can you conclude about the first differences of the average rate of change of a quadratic function? Oh, well, they're the same. They're equal.
Oh,
So we didn't really have to say what I was saying, but that's what's going on. The average rate of change is sort of a first difference. And so a first difference of a first difference is a second difference, which is why part C is true. Weird question. Should have gone slower. The average rate of change of the quadratic function f is 5. Oh, we've seen one of these before. From -4 9 to 5 to negative 5. It's 5. And then from negative 5 to 1, or negative 1, it's 2. What is the average rate of change on the interval 7 to 11? Well, I think I better keep drawing out these intervals. So the next one would be negative 1 to what? 3. See where that came from? These intervals are 4 wide. 3 to... No, they're 4 wide. 3 to 7, and then 7 to 11. That's the one we're looking for. So it gives me the average rate of change. It's a quadratic, so that means this difference should be the same. So from 5 to 2 is negative 3. And those are supposed to be the same. I think we're just going to have to piece this together here. So this difference would be negative 1. And this one would be negative 4. And this one would be negative 7. So it's kind of a pattern thing. (8a) Find the value of k given that p of negative 1/2 equals negative 4. Okay, well, there's a long way to do this and a short way to do this. The long way is plug in negative 1/2 and set it equal to negative 4. But that does not look enjoyable because I don't want to do negative 1/2 to the 5th. The short way is, do you know what the short way is? What am I going to need to do? Synthetic division. Careful, I'm missing an x cubed term. I'll synthetic divide with negative 1/2. And then what will I do? What? Remember, this is my remainder. So my remainder should be negative 4. Okay, that's that weird thing where if you synthetic divide and get a remainder, that's the same thing as if you plug in the original number. So this would be a great place to waste a lot of time on the test, right? You could plug in negative 1/2 and do it that way, and you'd have a nightmare on your hands. You'd get there, but it'd be much better to do it this way. Copy down the 16, multiply by negative 1/2. And we'll see if they rig this to give us nice answers. Nice answers most of the way anyway. Yeah, nice answers all the way.
It's positive 1.
Where did I mess up?
The negative 9.
Yep.
Which is an even nicer answer.
It is a nicer answer. So k equals negative 8. And again, that's the kind of thing that I'm worried about on your behalf on Thursday and worried about when I made the key. That's why the teachers will check keys with each other to make sure we didn't mess anything up. Part B, find the value of k given that p has a factor of x minus 1/2. Is this the same problem we just did? No. It's tempting, but no. This is, I need to synthetic divide with 1/2 and end up with 0 for a remainder. Maybe I should go a little bit slower on this one. So 16, 8, 0, 0, 0, 0. That's nice. 2, 1. negative 8, negative 4. So k minus 4 equals 0, so k equals 4. Okay, so here's a hint about some of the stuff on the test. Like, I probably should have gone slower and been more careful to get my 17 minutes. But after having walked through these notes today, I bet I could have saved some time on the test, having practiced this and seen this, rather than looking at the test and trying to sort of figure out for the first time how to do some of these things. So, I mean, as always, do the homework. It'll help you with the test. It's a pre-AP class. It's a really hard AP class, so you're not going to get, it's not going to be a 1-for-1 where, hey, this test question matches exactly number 6 on worksheet 3. You're not going to be able to do that every time. You'll be able to do it a lot, not quite every time, but your best bet for doing well on the test is do the homework. Make sure you understand the homework. All right, today's assignment is worksheet 6. That's Tuesday. Tomorrow there's nothing new. You've reached the end of the worksheet packet, right? There's no more notes to be had. So tomorrow is worksheet 7, a review, and then Thursday is the test. I'm thinking I'll do what I did the previous times with the review, where I will work a third of them in each of my classes, and then post all the 3 videos.